Hi everybody, thanks for taking the time to watch this video. This video is basically to give you a very brief overview of Wireshark itself and how to do a basic capture and save of the file so that you can send it through to your support person if you've got any voice over IP problems. This is probably the first step of learning about Wireshark, and over time you should be investing in yourselves and looking at the protocol and all the different faults and actually being able to read the Wireshark trace that you are doing or capture. So let's start off. First of all, why do you need to know about Wireshark? Well, basically, what is Wireshark? Let's start off with that. It's a network protocol analyzer. It's great for analyzing network traffic. You can see what's happening across it, and most IT industries use it. Well, pretty much all IT industries use it for analyzing anything from network performance, network problems, etc. From our perspective, when we're using voice over IP, we need it, and we do need it to see what is actually happening to our voice across an IT network. Because voice is probably the most demanding traffic you can put across a LAN network, we have to have it set up and working correctly. Otherwise, the customer will complain of problems with their voice over IP and / phone calls. And the reason we are the ones that get this complaint is because we are at the end point. We are the ones that receive the voice and make the voice calls at our endpoint equipment. And just because they've got a problem on your phone, for example, or a customer's got a problem on their phone, doesn't mean that it's actually the phone or PABX which is at fault, because any issues that come across the network can come out from a telco, can come out from the cloud area, from the customer's local router, local LAN, etc. No matter where the problem is, its display point, or where it's actually going to show itself, is at the customer's phone. Okay, so you could look at the phone and say, well, my phone's faulty. It's not actually the phone that's faulty, it's the network. So to see this, you need to be able to get the information off the network and help you understand where the problem is going to be so that you can address it moving forward. This presentation is basically just talking about doing a very basic capture and being able to save it and send it off to somebody who can actually read the protocol for you. But as you develop in the comms industry, and if you're coming across from your traditional comms to the voice over IP comms, you need to be able to start understanding and reading these captures, because it's actually telling you what's going on. And it is an absolute tool that you need to be able to say, go back to a telco or back to a equipment provider and say, I have a problem and it's proven into XX network. Now, I fully understand that moving across from a traditional comms analog hybrid type scenario through to a pure voice over IP scenario or tracing voice over IP traces is scary. It's an unknown area. A lot of us have been in the comms industry for many, many years, but as you get to use Wireshark and get more and more captures, you'll get more and familiar with it, you'll begin to understand it, and you'll see the absolute benefits of why you would want to use Wireshark. My advice to you is watch a lot of YouTube channels out there. There's a lot of information about voice over IP out there. This one is just to help you out, get a capture so you can send it to your support person, but they will tell you about one-way speech, they'll tell you about jitter, why things aren't registering, RTP events. It just goes on and on and on. And it's a mine of information. And as you become an expert at this, because if you do, you continue to every day do a trace, learn how to trace, talk to people, learn, you'll get more and more proficient. In summary, if I wanted to put it in absolute plain English, the Wireshark is today's test bed for voice over IP. Okay? In the old days, we would never, ever have gone out to a customer's premises without taking the good old Batinsky, the old test unit, so that we could go across a CO line or a central office line or even a PABX line and test what was happening. Did we have dial tone? Could we dial out? Could we dial in? Was there humming on the line? Was the calls ringing once and tripping and cutting off? We all knew what these faults meant, and we would never imagine going out to a customer site without one of the test butts. If you're going to be doing voice over IP moving forward, you must learn Wireshark, because if you don't have Wireshark in your toolkit to use and analyze problems on your customer sites, just imagine yourself going out and trying to find a ring trip cut off or something, or humming on a line in the old days with analog. It would be absolutely foolish not to have a test butt back then, and it's foolish if you don't actually start looking at the Wireshark side. Okay, so how do we capture and where do we capture the Wireshark traces? Well, first of all, I guess we have to understand the structure of a basic network. First of all, pretty much all IT networks nowadays that are going to be running VoIP across them generally go across and use a switch to connect phones to. And what we've basically got here is an example. On the left-hand side of a hosted solution, we've got voice over IP, phones, and we've got PCs, and they're all going to a network switch. Now, the thing about a switch is that all of the traffic that's going to it and from it, from each device on the PCs, and as you can see the example working there, goes from a computer directly to another switch port. Okay, to capture voice over IP, we actually have to put our capture tool, or our Wireshark, inside the stream. E.g., the stream has to go through the PC, our PC port that the Wireshark is running on the laptop, so that it can see the voice over IP traffic. Now, in a normal switch, we can't do that. For example, in this picture here, we've got the switch, and let's say that's our capture PC there, or even this one here, next one in. If this PC here is sending traffic, it's actually bypassing the port of this one, so we can't do a capture. So we need to have a method on how we can capture the voice over IP traffic across a LAN switch. So let's talk about the options. We've basically got three of them. The first one is that on a switch, or some switches, the cheaper end or entry level switches, not so much this, but as technology changes, they're getting more and more, is you can set up what you call a mirror port switch. Now, the two diagrams here are basically trying to explain this in graphical forms. For example, on the first one here, we've got two voice over IP phones, and they're sending traffic in, and it's going out to that phone. But this mirrored port here is actually capturing all of the data packets which are going backwards and forwards between these two phones. So if we've got Wireshark running here, we can actually see the VoIP's traffic on these two ports here. The second diagram over here is just giving another example of this. We've got port A and port C talking to each other. Okay. Port D, or port number 1, sitting here on PCD, has actually got a mirrored port setup. So this port here has been set up to receive whatever traffic goes across these two ports. So any traffic that goes across gets immediately also sent to this PC. That's where our Wireshark is, and that's where we can do our capture. The second method we can use is a hub. Now, there's not so many new hub options around. You can still buy them online, I believe. You can either get an old one or you can get a cheap new one. Generally a 10-100 type unit on speed. But the fundamental difference between a hub and a switch, without laboring the points of everything else, is that whatever happens on one port is seen on all ports. Hence why they're not the preferred option nowadays for a network backbone switch, because they're not fast. All the traffic, it really loads up the hub with the traffic. So, for example, if we had a phone here, and that's talking out to the network, and we had a Wireshark here, no matter what is sent or received on this port here, will automatically go to every single port. So if you have got a hub in your toolkit, just a little baby one, you can actually use that to plug your phone through or your PABX through, and you can actually monitor and capture the traffic through the actual hub. I guess the issues, or my personal opinion of this, is that a hub, unless it's a very small unit, is difficult to carry around because it can be larger, and you also need a power source. E.g., you need to have 240 volts with you. So if you've got one and you're using it, great, no problems, but it's not my preferred option. You can mirror a port, but sorry, I didn't mention with mirroring a port, the issue is that you need to have access to the actual switch itself. The switch needs to be capable of doing mirroring, and you need to be able to access it. Whereas a hub, you don't have to do any programming. You just carry one around, you plug it in, and away it goes. But you've got a power supply issue. The option number 3 is probably my preferred one because it's simple. I don't have to rely on any IT people to do it. What we have here is this is an RTEC tap, but there are other taps out on the market. So this is what we have, and we can supply you guys. But it's an RTEC tap, and fundamentally what it is a little plastic box, actually not much, a little bit bigger than what this picture is up here. And it's got 3 ports in it. And in the next video that comes after this, you'll see me actually setting it up and using it. But it's got 2 ports on one side and 1 port on the other. The 2 ports, you've got an in port and an out port. So we just basically put our phone or PABX in one port, and then the switch that it used to be connected to in the other port. So it's actually in line. On the 3rd port, we put our laptop, which is running Wireshark. Okay. And the advantage of these little units, which I really like, is that you can plug them into the USB port of the laptop, and you've got power. In cases of this, so no matter where you are, it's just running off the battery of the laptop. The other thing I really like about them is I had a large PABX running VoIP and dedicated VoIP, and we had some problems with the network. So there was a Cisco router that the VoIP actually ran through, and I plugged the tap into the USB port on the router and left the little tap sitting in the main frame with a network cable going right down to the PC, which is down on the floor about 5 meters away, and that was just sitting there running 24/7, monitoring the VoIP off dedicated power. So nobody unplugged it, nobody played around with it, just worked. So this is the RTEC tap. This is what I'm actually going to be using to show you how to set up the actual physical equipment for doing a trace. I'd like to show you how to set up a capture. When you're doing a voice over IP capture, you can do a capture using either a hub, a mirrored port switch, or in this case, I'll be using an RTEC SIP box to capture the voice over IP traffic. Golden rule of capturing voice over IP traffic is that you must be capture in line with the voice over IP traffic. E.g., I just can't plug my laptop into another standard switch port and capture what's happening on the port next to it, for example, unless that switch has got capability to set up a mirror. Using an RTEC SIP box is just a simple mechanical way, literally, to set up a voice over IP trace. So let me just show you what's in this box. So when we open up the box, what basically you get is a set of instructions how to set up the unit with diagrams, etc., all on board. Put that to one side. This is the actual SIP box itself. You've got 3 ports. You've got 2 on this side and the other on that side, a little USB power pack. This is where you basically are going to put your SIP device in and out. E.g., on the back is a label here. You've got network and SIP device. Now that device, as I've already pointed out, could be either a PABX or anything else. It's a 10100 mirror port, and when it's powered up, and these are 2 putting the traffic through, your 3rd port here connects to your laptop, and you can capture your Wireshark trace. So if I'm going to set this up now, all I need to do is get the USB cable that comes with it. I will plug that into here, like so, and that will just simply plug into my laptop USB over here. I'll just power that up. You use your laptop USB. There's these lights are coming on, so it's powered up. We could use our laptop USB, or if the router actually has got a USB port on it, it'll actually power this as well. For a second, we've got an extra network cable that comes with it. So all we do now is we unplug the phone. Now, if this is a PoE phone, e.g. your switch is a PoE, you're going to have a power source. In this case, my phone has got its own power source, so I'm going to plug this, and if you look at there it says SIP device in this port here, so I shall plug that like so, and then I take the cable that came with the SIP, RTX SIP, plug that in there, I'm going to place that there, and then plug him back into my switch like so. Okay, then I take my laptop network cable, which is hanging here, and I can plug him, cables everywhere, into my box like so. So that's basically it all set up, ready to go now. So it's powered off the laptop via the USB here. This is the where I pick up the Wireshark traffic for the trace I'm going to take, and this is the in-out mirror port. Now, again, reiterate, you can use this to capture on either a IPPBX, phone, network, whatever you want. All you need to do is make sure that the unit is in line with the traffic. You don't have to worry about mirrored ports or anything. Simple, out of the box, carry it around with you, capture. Okay, so let's start opening up a Wireshark session here to do a capture trace. So you should have installed Wireshark on your PC, and this is pretty much what it looks like when it opens up. This is just going to be a very basic introduction on how to do a capture. So we go up here, we click capture, and then options. Okay, so first thing it's going to show us is all our network connections. Here's our wireless, there's the local area LAN, and a few other things there. So it's my local LAN port, which is using the RTX tap. So I click into that. It's asking me, I could then also go output, where do I want to send them. So if I go browse, it's going to be, I've set up a file for capturing, and if I want to actually even set up a name, I could go just capture 2. You don't have to name it at this point in time, but just to show you the outputs of where it's going to save it for you, it's quite handy. You've got other options of create multiple files after X amount of time, etc. So, but you can look at that later at this particular point in time. Start off with the basics first. So that's it, we're ready to go. So if we actually go start now, the Wireshark is now actually capturing what you've actually got running. Now, it's capturing a whole heap of network stuff right now. Every little thing that's going across that, between the phone and across the network, it is capturing. There's filters up here. These are your friend. Get to know them. One of the first ones you could probably use is SIP. Now it's only filtered out the SIP communications between the phone and its server. Now this phone is the Fanville phone we showed you earlier. The server is actually sitting in a remote office. So at the moment it's only done a basically re-registration and status okay. So let's just put a call through. Let's see the traffic get generated. So I'll just make a call to this phone from a cell phone. Phone call comes in. You can see the invite coming through, and it's trying, and it's also telling me the phone is ringing. So I now answer the phone. Status okay. I'm now talking 1 2 3 4 5 6 7 8 9 10. That speech. 1 2 3 4 5 6 7 8 9 10 from the cell phone. I'm now going to complete my call and hang up. And it'll say goodbye and status finished. So I'm just going to stop there, because that is the capture that I actually wanted. Now, if I wanted to save this as something, I could simply go save as and make this a capture that I want to send off to my support people, because I'm not quite just saying, you know, you're new at this, I understand that, but you need to send a capture to your support people. So you go support help speech issues. Now that's okay for the file name, but when you do send a report and a capture to your support technician, please give as much detail as you can about what you've done this call, what time you made the call, what number was it from, what number was it to, a detailed description of what actually the problem was. The more information you can actually give to your support technician, the better. Software versions, etc. of the system should be included without even me mentioning that. Okay, so I've shown you, this is basically the capture is done. It's now a PCAP file sitting down in the with the directory that we had. But let's spend a couple of minutes just having a quick look at this. You've seen now, but by using the filter box, there's a whole bunch of commands you can use in here. By using the filter box, we can actually either have no filtering and have massive amounts of traffic and it's all over the place, or you can simply filter it by SIP if you want a nice clean example. Or I could actually, if I just wanted to see the RTP streams, I could go RTP, and there's my RTP transmission receive. And by the way, this is also telling me that G711 codec that it's transmitting in. It's telling me about my destination ports and my source ports. Remember, the voice over IP sends speech in one port and receives in the other. But that's something that you need to read up and do a little bit of education with yourselves on. One thing I do want to carry on to show you though is the telephony option here. So if I click telephony and go VoIP calls, the Wireshark's now going to tell me how many VoIP calls I've actually captured. Now in this case it's only one, because I've been very clean capturing only that phone. Okay, if you're capturing a PABX, you may have 5, 10 calls, whatever. The key thing with doing a capture, particularly if you send it to a support person, is to make sure that you've got as finite or as capture what you want to capture excuse me, and then send it. The more calls that are to be filtered through, it gets more difficult. If we actually now highlight that call and go to flow sequence, this is actually the VoIP call flow of the invite, the trying, the ringing, the phone saying okay, acknowledging each other. Then you've got your two RTP streams. Now one is transmit and one is receive. You'll see the ports that it's using. One side of the ports over here is 21384, the other side is 100004. You might have a one-way speech issue that you're trying to trace. This happens, particularly when you're running behind a NAT. A router might block, or even it proves out to the network. And then it's got the bye, as in hang goodbye, status okay, and that's it, the call's done. But now, because I'm using G711, I can actually even play the streams. Now you'll have to excuse my laptop because it is. There we go. Just have to hit that twice. This is actually the RTP stream. So this is an RTP player built into Wireshark, okay? And because my system or my phone is set up to G711, it's actually recorded the speech. So even to the point, I can play it. Okay. Now the reason it's showing you two lines, two streams, the grey and the blue, is one is actually the transmit and one is the receive. So if you've got one-way speech using this capture, and I've got one-way speech and I want to prove it safe outside my phone system towards the network or into my phone system, whatever way, if I can hear the speech from the phone going out and I can hear the received speech coming in from the network, everything is fine. But if I can, with the system, if I send out my transmit speech, but the other end isn't getting my transmit speech, it must be blocked somewhere between where I've done my capture and where the destination or e.g. An ITSP provider, for example. Okay. The Wireshark is the test butt of today. It's like a test telephone that you had. You need to know this. You don't need to go into any great detail. Learn, keep using it, practice. Buy yourself a voice over IP phone. Have it in the office, have it at home. Do captures. Understand what jitter is. Understand what one-way speech is. Understand what is a correct SIP registration, what isn't a correct SIP registration. Okay? It'll tell you if you've got the wrong password. It'll tell you if the ISP is even responding to you. Okay, so that's pretty much it. As I've already pointed out, you can save the file and you can send that file to your support person via email, and they can have a look at it. So when you do want to have support on any voice over IP equipment from your support person, I'm sorry, but you must provide a voice over IP capture, Wireshark capture. Otherwise, nobody can really help you. They can say, have you checked this? Have you checked that? And that's it. Can't do much more. Now, ISPs are not perfect. You need to prove it one way or the other. And before you report an issue to any ISP, you must have a Wireshark capture to show them that, yes, it is outside the phone system, because the first thing they're going to do is turn around and tell you, phone system. Okay, guys, we'll carry on with the presentation. Okay, guys, I hope this helps. This is really honestly 101 stuff. It's just to teach you how to do a trace. And the reason you need to do it is because if you don't actually understand how to read the Wireshark trace yet, don't worry, give it time, you'll be able to. But you'll then be able to capture some information that is really going to be helpful to your support people who is looking after your equipment. Doesn't matter if it's a PABX, doesn't matter if it's voice over IP phones, doesn't matter if it's paging equipment, doesn't matter if it's intercom equipment. You need to be able to do a capture, because one of the first things your support person is going to ask, if you ring up a help desk and say, I've got one-way speech, I can tell you straight away, it's probably going to be a port issue, blocking. It's either going to be in the router, or it could be in the ISP network, could be anything. We don't know. So first thing I'm going to ask you is, great, no problem, send a Wireshark trace, please. And then I'll be able to help you out. Otherwise, I'm just going to have to turn around and say, well, it's probably a block port, but we don't know where it is. You need to prove it out of the PABX. And you're going to go, well, how do you do that? And that's about where we stop, because we need that Wireshark. No matter what you do, it's just like that test phone. If you've got a faulty line, the first thing you do is isolate the phone or isolate the PABX off it, and you put a test bed across it. Well, the first thing you guys should be doing, if you've got a suspected VoIP issue, is take a Wireshark trace, look at the trace, and prove where is it going. Is it out or in? Okay, I hope this helps out, guys. Any queries, questions, please feel free to contact us. And if you're looking for a RTEC tap, we can also provide that for you. Great. Have a great day.